When it is producing current, guys, can anyone say when it is producing current, either moving upwards or downwards? For example, I will keep stagnant position between the poles. Then what will happen? Is it the current will generate? That is what my question. Now, is it the current will generate, guys? Please respond. Sir, if man moves wire down, means the flow of current will be low, sir. Karthikeyan, already current will produce very less only here because it's a single conductor, a single wire, and as well as it is insulated copper wire. So doesn't mean that we people will never get influenced with anything. Okay, Karthikeyan? We people will never get anything, any current. Any
not deflecting left side.
Deflecting left side, right side, that is what. Now you tell me if it is kept stagnant position, then what is happening? This is the horseshoe magnet and I kept just, there is no movement, there is no relative movement. So only stagnant I kept like this. Then is it any kind of current will produce or not? Anybody? Please respond. No? Nobody is speaking. That is what. So once again, I'm saying, all of you remember, when a horseshoe magnet is fixed like this, you can see, imagine they are keeping like this, North Pole and South Pole. Okay, sorry, like this. So now the magnetism is flowing like this. So now conductor is, when it is in relative motion only, it will produce the electricity. When it is stagnant position, if I'll kept between the poles, then the galvanometer, it will come to the 0 mark because no current is induced when there is no motion. All of you understand? Only it will produce the electricity when the conductor is moving to and from motion or relative motion, means up and down. Then only the current is produced in the conductor and we can notice the deflections in the galvanometer. So one time up, the galvanometer is deflecting into one direction, and if it is pushed down, it is deflecting into the opposite direction. If it is kept stagnant position, then no deflection is in galvanometer because no current is induced in that time. Understand, Padmavashini? Please respond. So now if you notice it, so this is the phenomena which we will use to induce the current in the conductor. So you can see the movement of wire. The movement of wire in a magnetic field only can produce the electric current. So we can generate the electricity by moving a wire continuously in the magnetic field between the poles of a magnet, to and from motion, up and down, up and down, up and down, everything. So that is only we can see. That is only the principle which we are using in producing electricity through generators. But generators not the straight conductor. So we will use a rectangular coil like a electric motor. We will use rectangular coil, correct guys? ABCD rectangular coil. So that ABCD rectangular coil. So here it will be, instead of up and down, it will make rotation. Understanding? Movement or rotation of a rectangular coil between the poles of a horseshoe magnet, then it will produce the electric current or electricity. So that is the thing. That is the phenomena of electromagnetic induction, which is used in the production of electricity by a generator. So here I am using a straight conductor, but in generator, that is the same horseshoe magnet, but a rectangular coil, ABCD coil will be there. So that rotation of that rectangular coil between the poles of a horseshoe magnet, which will generate the electricity. So continuously it will rotate so that it will produce the more amount of current. So that is what you have to remember. So also you remember here, two things I want to say you, very, very important. Have you noticed it, guys? By changing the direction of by changing the direction of conductor, like you can see the direction of current, and it is also changing, the deflections is also changing. Have you seen? Moving up, the current is producing in one direction. Moving down, the current is producing in opposite direction. Yes or no, Karthikeyan? Have you understand? So that is you have to remember. So the direction of induced current can also be reversed by reversing the direction of magnetic field. Understand, everybody? So the same way how it is reversing the direction of current here, moving up one direction and moving down another direction. Same way, if I'll replace the magnet, suppose now north pole to south pole acting like this, and here also north pole to south pole. Now if I'll reverse it, here this side north pole and this side south pole, then the direction of currents will changes opposite. Understand? So always the induced current is we can change the direction of induced current by changing the direction of magnetic field. Always you have to remember that. So the same principle which we are using in electric generators to produce the electricity. And also remember here, like as Karthikeyan asked, sir, we need to move the conductor between the two poles of horseshoe magnet. No need. Okay. When the wire is moved between the poles of a fixed magnet, then it will produce what? The electric current is produced in the wire. Or else we can do the reverse of this. That is also will produce the current. How, sir? Means fix the conductor. A conductor is fixed. Now I took horseshoe magnet. Now horseshoe magnet is moving up and down. Can you able to understand me, all of you? So that is also true. The reverse of this is also true. If a wire is kept or else a coil is kept, that is the coil we will use in electric generators. This is a simple one experiment. So that we are using a coil is fixed here. Understand? So this is what the coil I fixed. Now I took a horseshoe magnet, and if I keep on moving up and down the horseshoe magnet, then you can see when a fixed but a magnet is moved inside, even then a current is produced in the coil. So that is what you have to understand. So now we will demonstrate the next experiment, like a coil and the bar magnet is going inside, or else the coil is pushing forward and backward of a fixed bar magnet. That is all the experiments we will study in the next class. So you remember, either conductor is need to pass up and down between the poles of a horseshoe magnet, or else conductor is fixed and horseshoe magnet is moving up and down in a on the conductor, then also the electricity will be generating. So this is the simple phenomena which we are using in generating electricity. But in electricity, instead of straight conductor, like electric generators, we will use a rectangular coils. Rotation, movement will be rotation. Here up and down, there rotation it will make. So that is only the phenomena which will produce the electricity from the generators. So this is the first experiment which we will use to find that when the wire is down, the magnetic field, even it will produce the current. But if you will see, it is reversed, opposite. When it is moving up, then another opposite direction. So we can say that the direction of current produced in the wire is also reversed by moving downwards or upwards. So rapidly, if you keep on moving, it is used to produce the magnetism. Keep on, we can see the deflections in the conductor, like galvanometer, we can see that. So that is what you have to remember. So this is only, we used to say, the first experiment which we can see that the demonstration of electromagnetic induction by using a straight wire and a horseshoe type magnet. So as we know, we don't have any kind of galvanometer, but we have conductor, horseshoe magnet, everything, but no galvanometer, and we cannot show it practically. But you can see in lab, if you go, unfortunately, you can see that in the lab, it's a simple experiment. You don't need to worry much about things also. Easily we can see that experiment by moving the conductor between the horseshoe magnet. So we don't have galvanometer, we cannot. But galvanometer is very important because next experiments and all, more left, right directions also will come. For this experiment, we no need to remember left or right. You can say one, it will deflect to one direction, and if it moved up, if it deflect to the another direction. We are not mentioning about right or left. We are mentioning when the conductor is moved up, then the galvanometer the current is induced in the conductor, so that the galvanometer will deflect into the any one of the direction. Then if the conductor is pushed down, then the galvanometer, again the current is induced, then the galvanometer needle will be deflecting to the opposite to the first side, first direction. So that is what you have to write it. When the conductor is kept under stagnant position, no movement, only relative motion only, it will produce the current. If it is kept stagnant, then no deflection is observed in the conductor. Understand? Kritika, have you understand or not? So that is you have to remember. So this is all about how we need to produce electricity with the help of magnetism. So that is what we used to call as electricity from magnetism. Even you can see the singers, they will sing in a mic, that phone, that what we can say mics, correct? So that singers also, they will rely on this induced currents in a microphone only. So that mic, how there it is coming the song, that is also, they are also, the current is induced with the help of magnetism only. So they always rely on the induced current in a microphone. That is also importance of where we are inducing current, real life application with all the mics, speakers, everywhere. The induced current is only with the help of magnetism. Okay. This is the first experiment. Then the second experiment, which is given in our textbook. So that is only demonstrate electromagnetic induction by using a coil and a bar magnet. So now we'll take one coil and the next bar magnet. So we have bar magnet and as well as we have a coil. So practically we can do it, but we need galvanometer. But with the circuit diagrams, textbook given only single diagram, but we'll make a different kind of diagrams for all the cases, and everything we will study in the next class, like how the coil will go inside, how the current will move, and how the galvanometer will deflate. If the coil magnet is coming outside, how the coil will, how the current will flows, and how the deflections, everything that is only the directions of the current is very, very important. So that is we will study in the next class. So to identify this only, we will use a Fleming's right hand thumb rule for directing direction of induced current. So that one we will use, we will study in the next class. And this direct current, later direct and alternative currents, and after that it is everything electric generators is deleted. So till there I will teach you everything, and later we will see the remaining things. Okay. So this is all about it. With this I will leave you today's class. Then tomorrow's class we will see what it is. So thank you all of you. Bye. We'll meet in the next class.